So one type of problem that comes up with the chain rule is sometimes we have a function where all we really know are its values at certain points, and we want to apply the chain rule sometimes in combination with a function that's made more explicit. What am I talking about? So here I have a pair of examples up here. Let's do the first one. So what we have here is h of x, which is defined as f of the square root of x, and what we want to do is find h prime of 4. So if h of x is equal to f of the square root of x, then that means that h prime of x is equal to f prime of the square root of x times the derivative of the inside function. It's always how the chain rule works. Well, we know by now the derivative of root x is 1 over 2 root x. So that means that h prime of 4 is going to equal f prime of the square root of 4 times 1 over 2 times the square root of 4. That equals f prime of 2 times 1 over 2 times 2, which is 4. So f prime of 2 is 5. F prime of 2 is 5, and we know that from the table up on top over here, and we multiply that by 1/4, and that gives us 5/4. So that's h prime of 4 is 5/4. So for our next problem, we have k of x equals f of x squared over x times g of x, and the problem is to find an equation of the line that's tangent to y equals k of x at x equals 3. So here we have a fairly complicated combination of f and g, and we're mixing the derivative, mixing the function x itself in the denominator. So what we want to do is we want to write out an expression for k prime of x using all the rules that we know. So first of all, write k prime of x is equal to, I want the bottom function. I'm going to use using the quotient rule, so I write the bottom function times the derivative of the top function. The top function is actually a composite function. In other words, it's the square of f of x. So the outer function is x squared, the inner function is f of x. So that's going to give us the outer function 2 times f of x, and then times the derivative of the inside, which is f prime of x. So okay, so that's bottom minus the derivative of the top. Sorry, bottom times the derivative of the top. Now I need to subtract the top times the derivative of the bottom. So that's going to be f of x squared times the derivative of the bottom. I need the chain rule for this. So that's going to be x times g prime of x. Sorry, not the chain rule. I need the product rule. I mean for the bottom function. So x times g prime of x plus the derivative of x is just 1 times g of x. And then we write a very long division sign. And now we need to square the bottom, and that's going to give us x squared times g of x squared. So I need to evaluate this function at 3. And that's going to involve a lot of looking up stuff. So that's going to be k prime of 3. So we're just going to substitute every place we see x or g of x or f prime of x, etc., etc. We're going to substitute the appropriate value. So we start with this x, and that's 3 times g of 3 is 8 times 2 times f of 3 is 7 times f prime of 3 is 9, and then minus f of 3 squared. So that's 7 is 49 times 3 times g prime of 3, which was 10, plus 1 times g of x, so that's 8. Remembered that. Oops, sorry. G of 3 was 8. So there's the top. And on the bottom we have 3 squared times g of 3 is 8, and we're squaring that, and that's 64. Okay, so we need to do a little simplification here. This is going to be easier with a calculator. That's 3 times 8 times 2 times 7 times 9 is, sorry, 3 times 8 times 2 times 7 times 9 is 3024. And then 3 times 10 is 30, and 8 is 18. So I have 49 times 18 is 882. And then on the bottom we have 9 times 64, and that's 576. So this is 3024 minus 882 is 2142 over 576. Could reduce it, but there's no real reason to. So okay, so this is going to be the slope of the tangent line at x equals 3. All I need now is a point, and I know that the point has an x value of 3. I just need to find its y value by plugging it into not the derivative function, but the original function. I need to actually evaluate k of 3, so that's going to be f of 3 squared over 3 times g of 3. So let's see, f of 3 is 7 and g of 3 is 8. So that's going to be 7 squared over 3 times 8, which is 49 over 24. So that's 49 over 24 is the point, and I have the slope, and I can write out an equation of the line in point-slope form. Y minus 49 over 24 equals 2142 over 576. Don't let the big numbers scare you, it's just a number. X minus 3, and there we go. Now you might wonder, is finding a derivative such as this one, where you have a combination of things like x as well as other functions that are known only from a table, is this, let's say, a fair question on a test? Answer, you bet it is.